You guys over here.
Computer science.
CS?
Computer science business.
CS business? Double degree here?
No, University of Toronto.
Okay, UT?
Yes, University of St. Paul.
Okay, awesome. We have lots of CS people. In that case, I will focus more on the non-CS questions for this, if that's okay, because that way we can get more coverage, because there are interview workshops that you can check out online that are happening as well right now for CS interviews, or like more software interviews. But I guess in case you have some gaps more on the statistics side or on the product side, then I can help talk about those too. Does that sound like a plan? Cool. I guess to give a bit of context, I go to Waterloo as well. I'm about to graduate. I study computational math, which is a fancy name for a math degree where I can take stats courses and some CS courses. And it has the word computer in it, so that's a good thing, I think. In the past, I've done some co-ops. I've worked in a couple tech companies in the US last year, and I've also worked here in Canada doing data science work. And I guess one thing I want to ask you guys is, are there any interview questions you've ever had, if you've ever done a data science interview that you got stuck on? Because I'm going to write them down here. We can go over those first. Otherwise, I can just kind of dive into like the different types. Nothing comes to mind? Okay, awesome. So one thing I want to note is that for data science, usually when you define data science, it's like the application of the scientific method to data. But if you look at job postings online, there are actually a lot of different types of data science jobs. So one example is product data science. And please tell me if you can't read my writing, I will try to write cleanly. Another type is engineering data science, so sometimes they call this machine learning engineering. Actually, we're engineering. And then there's research. The most experience I've had personally with interviewing was in product. I did do a lot of software engineering interviews when I was applying for co-op and internships. So, but I think I will focus more on the product because that's a lot less of a travel path for some of you guys who are at CS. I guess just to give a quick overview of what is expected of you during a data science interview. If you've done a lot of interviews before, sometimes they'll ask you a technical question. That's one type. Another question they might ask is something more general, like how do I make Facebook Messenger better? And that is a very open question. A lot of these answers can vary depending from candidate to candidate. Sometimes I'll ask you a stats question, like a probability question you might see in an intro to probability class. Or they might ask you something specific. So if it's like an advertising data science position, they might be like, oh, you know, how can we increase conversion rates on this ad? And by the way, at any point during this talk, if you guys want to stop and ask a question, just raise your hand. Or just yell at me. One of the two works. Okay, and seeing as you guys mentioned you're pretty awake, I guess one thing we can start talking about is maybe some examples of questions or the interview process. So yeah, I'll go over the interview process first. So if you're newer to the interview process, if you apply to a data science position, at least for tech companies, I've noticed they have a few rounds. Usually it's a phone screen where a recruiter will call you and they'll ask you, what skills do you know, what's your background, where have you worked, and just general information, and then they'll assess if they're interested in moving on to the next stage, which is usually a technical interview. So in my experience for product data science jobs, a lot of questions here take a bit from here and here, but they're actually sometimes behavioral questions. So I've been asked to talk about my previous projects and talk about things like communication, like how would I explain statistical significance to someone who's never studied stats, those kinds of questions, and those ones caught me off guard at first because I just was grinding questions on LeetCode and doing SQL questions on SQL Zoo, and I had not prepared for those at all. So I'd like to talk about some of those questions today as well. And so in the interview process, often you'll have a phone screen, as I said, and then after that you'll have a technical interview or a problem-solving interview where you are either coding live with somebody or you'll be answering a bunch of technical questions related to, maybe they'll give you a data set and they'll ask you to analyze it, and you have to come up with some insights. Maybe it's a take-home project and they ask you to make a slide deck or a PowerPoint or something and present some results that you think would be valuable to the business. Any questions about that so far? So then after that, pretty standard, you do a few interviews and then you might come on for an on-site. They might invite you to the company's headquarters and they'll talk to you in person, put you through maybe 3 or 4 more rounds of that same stuff, and then they'll come up with an answer or a decision for you. So I guess one thing I found that was helpful was when you are asked a question, you have to have a game plan going in for any, like a general game plan, rather than just answering the question right away. One thing that helps, and this also works for engineering questions as well as research questions. Like for example, if someone asks you to merge two sorted lists, you might ask, okay, what values are in the list? How big are the lists? Same thing with data science. Sometimes you'll get questions that are more open-ended, like, how do I measure if a billboard that I'm using to advertise is working? So that's kind of a big question, and then so a good way to start is to ask questions back to your interviewer. What kind of billboard is it? Where did you put the billboards? How many billboards are there? And then you can start narrowing down and starting to give them your thought process. The part that differs from just straight up engineering and coding questions is that they're actually evaluating your thought process, because a lot of the hard work that a data scientist does is actually in trying to figure out if, like getting from something ambiguous and translating that to a set of data questions, which you might be able to code up, or a set of questions that you might be able to go and try to answer, or hypotheses, and then coming up with a result. So we can start with an example, and we can start off with a product question. So here, let me pick a fun one. How would you quantify the influence of a Twitter user? So we can, I guess, collectively brainstorm and come up with an answer. Any suggestions?
Like the amount of people that follow them and like view any of their tweets.
Okay, so what data would you need to do that? What would you ask if I was the interviewer? Well, I guess what kind of questions would you ask me back?
Like, are you talking about like a particular user or just in general?
Let's say any general user. Yeah, you can continue if you'd like.
So like, you'd have to see like the amount of followers they have, how often they post, and seeing those numbers, you can calculate that like if they did post something, how many people would it reach, and therefore you can calculate the influence of numbers.
Okay, what does influence mean here? So you said you have a user, and then you can look at their followers, and you said how many people viewed their tweets?
Yeah.
So who viewed the tweets? Okay. And so could you come up, and for product-related questions, typically they'll ask you to come up with a metric. So a metric is just like a numerical measurement of the health or the status of something. So in this case, influence is a metric, but then you would have to define how to calculate that. So in this case, we have information such as who's viewed your tweets, how many people are following you. You know, on Snapchat, for example, if you're DJ Khaled and you have like millions of followers, that indicates that a lot of people might be viewing your stuff, and you can look at who's viewing it, and then that is like a good place to start. You know, popular people. But what if a lot of people viewed your tweets, but not necessarily influence other people's behavior, right? So, yep, go ahead.
So, like, would you go so far as to say, like, if you just if you saw the tweet, that doesn't count for as much as, say, if you comment on it? And then if you go further, like, depending on what you comment, if you comment, like, something long, not too familiar with Twitter, if you comment, like, a very long comment, then clearly you were more affected by the tweet, I suppose.
That's a really good point. Really
Maybe
good
if
point.
you like share it, but I don't know what the Twitter term for that is, to like another user,
Mhm.
maybe that's worth more than just a regular comment, right?
Or
If
just
you
a
have a
view.
very short comment, you can say that maybe they were just like, haha, great post, or whatever.
Totally, okay. And we had a hand up here. Go ahead.
Yeah, so I agreed with him a bit more, like it's more about how many people interact with the actual tweet.
Okay.
And maybe,
Interaction.
like, if they were to post something, if they were to like give you a link to a website, how many people would actually click on it and interact with it? I mean, there's a lot of celebrities with many followers, but if they're constantly advertising things, there's not, you know, many people who are gonna click on said item instead of just, you know, passing it by, because
Right, so
It's
the
like-
natural question, in addition to what you said, which is an awesome point, is do we have data on if someone clicks on the tweet? And then so now we're starting to go down this rabbit hole of, okay, what information don't we have? Because we pretty much have everything, because everything's online. It's digital, and Twitter is a big company and probably has the resources to get that data. So you can probably keep going through the thought process, and the interviewer will probably grill you back and ask you what assumptions you're making there. So one assumption here is that we have the data, and so then you could ask, do we have the data? And then, so I found a lot of questions typically go like this because they're very open-ended. There's lots of different ways you can do this. I know, like, for example, Facebook, they look at, I think if you look at things like in the news feed, if you look at it long enough, it counts as an impression. But if you skip past it, it won't count as an impression. So, or if you comment and share with other people, then that's a stronger indicator of engagement than, let's say, just viewing it, as you said. So, as you can see, we're starting to go down this rabbit hole, and then as you continue to formulate your answer, then the interviewer will eventually stop if they're satisfied, or they might ask you to, describe how you convert that to maybe a SQL query. If they then next say, oh, here's a table of the data that we have, what can we do with it? So that's just an example, more product-related question. And since a lot of you guys are at CS, engineering questions, you can imagine, are just things you would find on LeetCode. So LeetCode's a great place to practice questions. If you go on, for example, LeetCode mediums are typical questions you might get asked. And I would recommend, I guess, for the data analysis part, if you're ever asked to do data analysis or programming and algorithms, Python's a really good place to go because there's a lot of libraries for the data analysis side. And there's also a lot of abstraction, so you don't have to be, building lists from scratch in C or something. So Python's a good place to go for engineering. So I'll just Python here. Python's great. So I guess that would be an example of a product question. Another question you might be asked is more statistics. So who here has taken a statistics course before? Okay, so a fair number of you. Do you guys remember what a normal distribution is? Has anyone here heard of the term A/B testing? What's A/B testing? Yep.
Like splitting your user base into like two groups, changing some variable, and then seeing how each one interacts with the different.
Okay, yep, that's basically A/B testing. So as a data scientist, sometimes you'll be asked to run an A/B test, and they might say, okay, here's one group over here, and maybe, and this is the metric over time. Or instead of using time, let's not use time. But you might have the control group, which is the group of people that did not receive a treatment, and then they'll give you a number, and then a sample size, so a sample size, and then another number, and sample size, so sample size here, and this is the exposed group, so people who are actually exposed to it. So maybe a more concrete example of this would be, let's say we wanted to change the color of a button, just as a silly example. Not very silly actually, because people actually play with this. We want to change the color of the button, and we want to look at the click-through rate to see if more people click on the button. That's, if you're advertising or something, maybe you want people to click on your ad, so you'll make it neon green. And then so they decide to run this experiment, and their metric that they're using, as I described earlier, something to measure how successful the button is how many people who saw the button clicked on it. So, your metric here is views over clicks. And I guess that would go here, like under your numbers. And then they might ask, so, this is the metric for the control groups of the people who didn't see any change, and then the metric for the people who are exposed. How would you determine if that is, if we should make the change or not? Any ideas?
Well, I think first of all you try to verify that both your groups actually follow the same distribution.
Okay, what do you mean by that, distribution?
Gender, age group.
Gender, age
If
group?
you have some socio-economic status,
Okay, so
if
basically,
you're very groups that are unbalanced,
right.
then perhaps you're not really getting the A/B test.
Right, so that's a, yep, in the back.
I just wanted to anchor based on the segments as well. Like in normal distribution, there will be different clusters based on different factors. For example, client demographics, as we just talked about over there.
Right.
There can be like other factors involved as well. And by studying those different segments and how they are adapting to what we're launching in market. For example, functionality, and we're accessing whether, we're just testing whether they like it or not. It can be really based on not just client demographics, it can be based on other things as well, based on their needs. In order to really understand the likelihood for them to really click on that button.
Right.
I don't know. It's like
So those are some good ideas. So basically, your concerns, both of you, are that the group that's controlled, that isn't seeing the color change, and the group that's exposed are not actually the same. So there are these intrinsic differences between them that we didn't account for when we're just comparing. Hey, is this number bigger than this one? Are more people clicking, the colorful button than the rainbow button over the blue button? Yeah, so we can start going down this whole other train of thought and start to question if our A/B test was set up correctly. And that's actually a popular interview question, is to ask, how do you know if your A/B test is biased? Bias here means that it's not giving a true representative estimate of what you're trying to guess here, or like the difference that you're trying to estimate. For example, if the two groups were different from the start, for example these two, then you can't compare them because there's already a difference. And so if you see one's bigger than the other, maybe it was already like that beforehand. So it's kind of important to list your assumptions here, and the interviewer may say you can assume this, you can assume that. But it's always good to ask lots of questions back to the interviewer, because now you can ask, is this A/B test fair? Like, can we assume it's fair? And if they say it's okay to assume it's fair, just like if you're doing an engineering interview, can we assume that this is only a string input? We're going to need to write test cases for that as well. Then you can proceed. So assuming this A/B test is fair, and that we set up our A/B testing framework correctly, then what? So these demographics were handled already, these differences that may occur are handled due to randomization. What do we do next?
I mean, we could compare distributions
Of what?
of case group and control group
Mhm.
with regards to the metric that we're trying to measure.
Okay, so in this case, it's an aggregate metric.
Yeah.
And so the aggregate metric in this case is the click-through rate. So views divided, it should be clicks divided by views.
And if we can assume that it's normally distributed,
What?
the click-through metric.
Okay. Why can we assume it's normally distributed? Why can we assume it follows normal distribution?
Well, we would have to check that in a good practice.
Right, and this is why A/B testing is popular, because you don't have to. If you're under the right conditions, so this takes us to kind of the next place, which is you can get a lot of stats questions. Is anybody familiar with the central limit theory? Got one hand in the back? Okay, so you can read about it afterwards, but it's an assumption, or it's a theorem that says that if you have a bunch of identically distributed random variables, which are just summed together, then you can actually if you calculate the mean of a sum of random variables from an unknown distribution, the distribution of that estimator, you might have seen this in your stats classes, like you have this, and you have this tilde thing, because this is a random variable in and of itself, which is equal to the sum of a bunch of other random variables divided by the whole total number of random variables. This will actually follow normal distribution with some properties. So you don't have to check the normality assumption under the right conditions. Like if each observation, like every time someone visits a page, they have the same propensity to click on your button, then you can run a t-test on it. A t-test is a statistical test to make sure that, if I have a number that's this value, let's say over here, and a number that's this value here, is this difference actually meaningful? So this brings us to another class of questions you might get asked during a data science interview, which are stats questions. So I found a few resources, I can list them out afterwards, that were really helpful for me to review statistics, because as someone who was switching, I used to work mostly in finance, and then I switched over to tech and more data science stuff after. I had to review a lot of stuff from the second year because I hadn't taken stats in a while. But they might ask you something like, what is statistical significance? Or why is that important? Does anyone have any thoughts on that? Or what is the definition of statistical significance? Yep.
Roughly it's basically, it goes against the hypothesis that your statistical data is purely because of sampling or,
Right.
basically means your data makes sense.
Yeah, it's so, another way to phrase it is, it's a meaningful difference. So these two numbers may be different, but that could just be due to chance. How do we quantify that chance? Well, that's why we have, we have stats because we try to quantify unknown differences and try to see if that, if there's a good chance that it's a meaningful difference, then you can make a conclusion. So why might that be important? Why do we care? Like if two numbers are different, then they're different, right? Going back to this is a number that can take on many values. This number here might have a distribution that looks like this, and this is the value we observe over here, or we observe values over here. Yep. Oh, sorry, that's the raising hand. So but we only have one experiment, so we only get one number from this, huge range of values. So it's kind of uncertain. When they ask you a question and they give you this, you don't really know for sure if this is the closest to the true value, but you can say things about how it's distributed. So it's likely to fall somewhere around here because most of the values for our click-through rate should fall somewhere here under the set of assumptions if you use the central limit theorem. So A/B testing kind of falls back on a lot of statistics. Good resources we can look at for stats. If you go through any introductory stats courses, you'll see things like z-scores, you'll see things like t-tests, chi-score tests, etc. They kind of creep up a lot when you're doing more products or analytics types of work rather than just engineering work. Any questions on that? So, I'll just bring up the next set of things. Is anyone here familiar with machine learning? Have you worked with machine learning before? Okay, a few people. So I could say that falls under, I guess, a technical kind of question, set of questions as well as stats. For example, if you're working with a data set and you see a bunch of null values in a column, but not all of them are null, what might you do?
Remove that column.
Sorry?
What's that?
Null values, sorry. So if I have a table of data, it looks kind of like this, and then I have all these columns. So let's say this is an employee database. So it says the employee's ID, name, department, and salary. And then, this is filled out all the time. You have values here. Sometimes the name is missing, so you might say null or NA or something like that. But you have some other ones filled out. Some values of salary are null. One question I've gotten before is, what would you do if you have missing information in your data set? So you have incomplete info. Yep.
So one thing you could do is you could take the average of that column
Mhm.
and fill it in, or you can just drop the entire row.
Okay. So in the case, assuming everything else in this table is filled in here, where might the average idea? So taking the average value work. Yep.
Well, I mean, you would definitely take the average for salary.
So put an average in here.
Yeah. Probably drop it in because
Yeah, drop the name.
And drop the name. Why should we drop the name? Yep.
Check for duplicates first.
Check for duplicates.
Real
Okay.
data sets, there's a lot of duplicate entries.
Okay.
Usually-
And have you?
When we use the, how about we use the mean in the average when there is no outlier and use the median if there's outlier.
Okay, so now we're going down another fun rabbit hole, right? So there's all these fun ways we can impute null values, and so it will depend a lot on the context of the question. But for example, we might want to drop this column here, or sorry, this row here, and ignore it because the name is null. But if I told you that this is a unique identifier for every employee, does it matter if we have a name? It doesn't really matter because this is actually more important than the name. So in the context of this question, we actually care mostly about filling in the salary field. If it's useful to the question, we're trying to get an estimate or understanding of how we're paying our employees, then maybe we might want to impute the values here, and don't worry about the null here because it doesn't really matter. There's still an employee with a salary here. It's just we don't know their name. It's not relevant to the analysis. So yeah, these are really good points. Mean is one way to do it. Another way you might want to consider, or a question I could ask back is, what might be wrong with using the average? Yep.
If someone in the company is paid way more, like the CEO makes thousands of times more than the other employees, it'll bias.
Okay. So, for example, if you draw a distribution of all the values, it might look something like this. If you take the mean, where might your mean fall in this distribution of values? So, who here has not seen a box plot before? Box plot. You good?
I haven't.
Okay, so this basically tells you, this is the median value over here. This is where 25% of the data falls below. So they call this the quartile. So basically, maybe a better way to draw this would be if you use something like this. This is also another way to represent a list of numbers. You can just show where they all fall, and you know, the higher the area of a range under the curve, the more numbers that fall under there. Either or, but I guess the question is still, why might we not want to use the mean, or what might be wrong with using the mean? So as you said, if the CEO makes a bunch and everyone's making a lot, and there's a huge difference there, then the mean gets inflated, right? So what can we do instead? Yep.
Use the median value instead.
Why the median?
It's not influenced by the magnitude of each value that's looking at, just simply the amount of values there are.
Right, and that's a great suggestion. We can use the median, which is more robust to outliers, or like, you know, huge values that there's only 3 of them, but they could really influence your average. Yep.
So are we talking about this in the context of machine learning?
In the context of machine learning, what would your ideas be?
Okay, well, my thoughts are that if you don't have enough data, and like, say this was like potentially a CEO or something, if you fill in a value for the salary, you could be like skewing your entire data set, right? Because if this is someone who normally has a very high salary, you want your data set to know that like this person will have a high salary, but if you put a median, and that's significantly below what that person should have been getting.
Right, so basically you're saying that if we fill in what what the median salary is, we might be missing the fact that they could be also an executive as well, and that we don't have their salary. And so we're making a strong assumption here, saying, oh, well, the median is representative of everyone else's salary except the outliers. Is that kind of what you mean?
Yeah.
Okay, and so all these caveats that you guys are listing out here are things that you should probably state during interviews and say, we can use the average here, but there are these problems with it. Because as I said, a lot of these kind of questions, they're more asking about your thought process and checking if you're being rigorous and skeptical about what you are doing. That's helpful because like all models are wrong, but some are useful, is a famous saying in stats. The reason why we question ourselves a lot is because it's very easy to make a mistake early on and forget about it later, or it's very easy to make an assumption and not realize it's wrong. Or maybe like they're null because they didn't list their salary because their salary is so big. Like there's all these possible reasons, and so that's why it's important to ask where your data is coming from, and to ask your interviewer questions back so you can show that you're being thorough about it and not just saying, yeah, we'll just take the average, it's fine. Because that's dangerous to do. If you just take the average, you might be making a strong assumption about, you know, the distribution of your data. Any questions on that? Cool. I guess another question we could kind of talk about here, or another example is, sorry, just pulling this up. So maybe something a bit more general again, like we're talking about product questions. What's your thought process if you wanted to improve Facebook Messenger with data? What could you try, or how would you do it? So it's another one of those brainstorming questions. You can go down a rabbit hole, and your interviewer will ask you questions back, and that can go on for a few minutes.
I think it's worth asking, what's the goal? Is it trying to retain existing reusers? Is it trying to acquire additional users that for some reason are exclusive right now?
Right. So those are your questions to ask back to your interviewer, and your interviewer might say something like, because we're Facebook, we want to retain our users. We already have enough users, but maybe a lot of them are churning, which means there are a lot of them are starting to use the platform and they're leaving. So we want to keep people on Messenger and using it instead of using something else. Any ideas on that? Yep.
Analyze the reviews on my Google Play Store where people download Messenger.
Okay, I see. I could maybe ask back what biases that could introduce if you use Google Play reviews. That's a possible thing I could ask back. Do you have any ideas on that? Like what's wrong with you, or what could go wrong? I'm not saying it's wrong, what could go wrong if you do that? Or just be or like, if I was skeptical of that approach, how would you defend it? Oh, yep.
We could say like, the reviews could be faulty, like, you could just be aggressive.
Right, so it could just be like those things on Amazon that's 5 stars, but there's like that one review, and so you see 5 stars and then you see the number of reviews after, and it's, okay, I don't trust it anymore or as much. Any other ideas?
I think the reviews are always skewed to
They're all skewed.
negative experiences. I think that's quite well known in practice.
So intuitively, you're saying,
People who bother to review the app are
Okay,
most
so-
likely to have a negative experience with that.
so only if you're pissed, you'll write a review,
Yeah.
because you're pissed enough to write a review. Otherwise, you'll just keep using the app. So that's a valid assumption, or that's a valid caveat that might happen. Yep. Yep, yeah, so it's
Yeah,
fine face.
your reviews could be kind of biased because you would have no iOS users, for example. Like, your population is biased toward
Mhm.
one,
Android
like,
users.
like a mirror of the platform. It's not.
Right, you're not accounting for the fact that it's not you're missing Apple Store reviews.
Yeah.
I don't have an Apple device, so I don't know if they have reviews on the store, but I'm guessing they do. Yep.
Yeah, and considering that the hardware for Android phones differ more than iOS devices,
Mhm.
so there could be different user experiences, not because of Messenger, but rather other things.
Okay, that's totally valid. Yep.
There could also be different demographics that are more likely to post reviews. For instance, older generations might be like, what the heck is going wrong? And then they just put it down and then they don't even know that they can write a review. And then younger generations are constantly pestered for reviews. So a lot of us are desensitized to it and we've just become to the point where we won't review regardless some of the time. So at that point, what are the demographics that would affect who is actually responding? So you would have to figure out, okay, who actually writes a review?
Okay, so we're going down another rabbit hole.
Yeah.
And one thing to note during these kinds of interview questions is that you can't keep going down forever. You have to kind of, I guess, stop and ask, can we assume this, can we assume that? So let's assume that we have the data on Google Play reviews, on iOS reviews. So now we're measuring things like satisfaction, because if people are mad, they're going to rate 1, and they're going to write nasty comments and swear a lot in the review. But maybe the interviewer is more interested in how would you measure in the first place, or like what things would you measure to determine that you've improved Messenger, or like what are things you care about? So I've just mentioned earlier that maybe we want to retain users. So how could you measure that? Yep. Yeah, you go first.
Number of times the user uses the app, how long they're using it for,
Okay.
messaging.
What kind of data would you use to look at that? What would it look like?
Kind of like you can know when like the app's first used, you can see impression or something, how many impressions of whatever the first page. And like log into session start time, session end time, friend big message.
Okay,
Messages
so-
going out, messages coming in.
So some numerical measurable things we can say here is the time you logged in, all the times that someone logged in for like user A, the number of messages you said, and so now you know whenever they log in. But what if they're always logged into Messenger, like it's always on my phone? Maybe you could throw other suggestions like clicking on a chat head, or just pressing in to go to read a message, because maybe I only read messages I don't send. So that's an example as well. So then another rabbit hole you can start going down is like brainstorming ways you could measure the success of Messenger as a product, for example, and then the interviewer will fire back. So I guess in terms of product questions, that's kind of the format that I've seen a lot when I'm going back and forth with the interviewer. It's very open-ended. You can throw lots of suggestions at them. You can ask a lot of questions, and it ends up being often a discussion. Sometimes they'll challenge and say, why would you do that, or what might be wrong with that? And then I guess that's where you have to brainstorm assumptions. And one way I found to practice this is just to take anything around you that is a product of some sort and ask why it was designed that way. If it was designed using data, why was it designed that way? So why is this juice box always 200 milliliters? Maybe there's a regulation reason. Maybe they found this is the amount of juice people like drinking. How would they come to that conclusion? in a world where it was completely data-driven. Same with MacBooks. Why did they remove the headphone jack on their newer phones? Or Apple, why did Apple remove the headphone jack? Did they measure how many people were plugging in their headphones? Because they might want that. And maybe they realized that most people, like the frequency of plugging in your headphones isn't enough to justify, a thicker phone in their eyes. To practice these questions, it's a lot of just brainstorming with yourself, maybe brainstorm with a friend when you're sitting down and practicing for an interview, and questioning each other and saying, and always asking yourself and being skeptical, why am I making this assumption or why might this be wrong? Because in the real world, no one is going to interview you when you're doing your work for a company and say, what might be wrong? It's up to you to do it. And that's why they're called data scientists, because they're skeptical and they rely on the scientific method to find information, not just going on gut instincts. They have to not just use gut instincts, but they have to be rigorous with everything they do. Does that kind of make sense? Cool. So I'm trying to see the best way to list out some stats resources that you guys could check out on your, so you guys can use your devices. One book I wanted to recommend, I'll put this in the machine learning chat on Slack, is The Cartoon Guide to Statistics. The Cartoon Guide to Statistics it's an older book on stats, but it goes over all the key concepts that you might find in an introductory stats course, and it's in cartoons. It's not a manga, it's like more of a Western cartoon format, like you'd see in a newspaper. And in terms of practicing, going through the concepts there and being able to explain to a friend is probably pretty good. I've been asked many times to explain why A/B testing is done the way it is, or what is statistical significance, or what is a confidence interval. And if you have an intuitive understanding, you can always come up with the answer instead of just memorizing it. And when you're actually in the real world and you see confidence intervals and people are drawing those around, some bar charts, then you can say, okay, I know what that means, and in this context, this is a very narrow interval to have, so we're okay. And so it just helps you be more rigorous and thorough. One thing I found that was tougher switching into more of a data science job is that everything is a lot more ambiguous than solving squashing bugs or taking on tickets or building a feature, because a lot of it is the results of your work aren't as clear right up front. But for example, I can load a web page and it works. Whereas if I make a product change, it might not be apparent until later that someone messed up, or this was a really good thing to do. So I'm going to put that up here in the machine learning Slack. So I'm just going to list the name. You can probably find a PDF of the book online. Cartoon Guide to Statistics. So here, and if you take any introductory statistics course textbook, lots online, you can find practice problems for probability questions, because they might ask you questions about flipping coins or drawing balls of different colors from a bag. So I found this to be a pretty good book. So that will cover the fundamental stats that you need to be able to explain some of these things that you're doing as a data scientist, such as A/B testing or statistical significance. On the machine learning side, you may have heard of the course by Andrew Ng. So Andrew Ng taught a pretty awesome course on machine learning a while ago. He's a prof from Stanford and a leading researcher. That is a good place to go to learn about the different models used in machine learning. It's getting slightly outdated, but it's still pretty relevant to simple things like linear regression or logistic regression. So maybe I'll just post it here too. Or I'll edit the post and just edit unless I won't spam the chat. And then I'm also going to post here for SQL practice. A common on the engineering side, maybe it wasn't a Python question that you might get, but they might ask you a SQL question. You can go on SQLzoo.com, which has a lot of awesome tutorials and practice problems for SQL specifically. So I'm just going to post it up there. So that covers the SQL side. And I guess the last kind of question that you might get asked is just to talk about your previous work. And similar to what you've kind of just done with me here, we've done this together, was to brainstorm kind of what might have gone wrong when you made an assumption, how would you make a product better. If they ask you about something you've done in the past and how you would have made it better, then you can go through the same brainstorming process with your interviewer. Always ask lots of questions, tell them I'm assuming this, and I'm gonna have to go with this, or can I assume this, is that okay? Or do we have that data, or what data do we have? Those kinds of questions, because a lot of this is very discussion and brainstorming style, rather than, there's one correct answer and that's the only answer. Any questions on that? And there's this neat PDF called, I think it's 120 data science interview questions. Here we go. And someone posted them on GitHub, I think. So, and answers as well. These all are kind of categorized similarly. There's communication questions, so explain this, explain that. Data analysis, so you're given a data set and you're asked specific questions about the data, or like what is the R squared? Is having more data always better? And then there's questions about product metrics. There's of course programming questions, which you can do with things like Python or C++, and some statistical inference questions in this list as well. Cool. So, did you guys have any questions about that so far? Yep.
Like, do you have the background in software engineering?
Oh, I'm in computational math. So I used to be in math and finance, and then I worked a few co-ops in finance, and then I decided to make the switch to data science because it kind of opened up more opportunities in other industries for me.
So did you do like software engineering?
I did a lot of software engineering interviews because I thought I wouldn't get a job in data science. But then I was fortunate to get a co-op in data science, and I interned at a couple companies doing that, and I just didn't want to go back to software engineering.
So I guess like you still practice in software engineering. Like my question is really, like what do you like about data science?
Oh, great question. The thing I like and I hate about it, it's kind of like a struggle because you never know if you're 100% you're right. The system, if you program and build something, you can get instant feedback and it's very gratifying to see like your work being done. But as a data scientist, sometimes you'll make a recommendation. Like in the case of an internship, I'm only there. Most internships are between maybe 3 months to 6 months, or even sometimes a year. That's a pretty long time horizon when it comes to building features. If they're pretty small, or if they're like an intern project. But if you're doing things like making a huge product change, sometimes I would finish a co-op and the experiment just finished, so I didn't get to see the results. I don't know what I did, if it was really effective. All I couldn't do was set up the experiment, because setting up the experiment itself is like a lot of work on the engineering side. And so I guess it's good because you get to be a scientist, not just by title, but you're kind of being skeptical about everything you're doing, and you're reasoning with a lot of uncertainty and ambiguity. But it's also tricky because it's open-ended and it's more ambiguous. So it's easy to make incorrect conclusions, and you may talk to another data scientist who's like, no, you shouldn't make that assumption, that's really wrong. Like that's definitely not true. Like the data is actually collected this other way. There's only iOS users in this data set, so you can't make any conclusions about the rest of the users, or you're only getting a subset of users. So that can be pretty tricky. And I guess the hardest part of adjusting was getting used to that ambiguity, and being confident about your results once you've made a slide deck or you made a Word document, publishing your findings with the charts and saying we should change the color of this button because this is what the test results show, and these are possible assumptions of this analysis and caveats, but based on these assumptions, we should change the color of the button. So you never know if you're 100% right, if that makes sense.